Okay, so continuing on. Circularity and cylindricity. The circularity feature control frame in A establishes a 0.3 millimeter tolerance zone. All circular cross sections of the cylinder need to be within that 0.3 millimeter zone, but they do not exceed to be within the same zone. The cylindrical feature control frame in B establishes a 0.3 millimeter tolerance zone also, but the entire surface of the cylinder must be within that zone. All circular cross sections need to be the same tolerance zone. So, as long as it's within this zone here and this zone here, then you would be good. Profile of a line of a surface. So that shows a 10 thou wide two-dimensional tolerance zone and three-dimensional tolerance zone. There's parallelism. So as long as it's within 3 thou of that parallel. Perpendicularity. So it's got to be perpendicular within the 4 thou. So it could be leaning a little bit as long as you're within the 4 thou. Angularity. It's got to be 0.008 of that zone there, or that line there. Position. The GD&T position tolerance increases the tolerance zone from the traditional method by 57% by creating a circular tolerance zone. So, in old days, you didn't have what they call bonus tolerance, in that as long as if you're putting this 1 inch at 1.005, then you actually, the location of the tolerance can be over a little bit as long as the first circle, or the ending circle, is within that zone. Alright, some position feature control frames, the diameter symbol and tolerance amount indicate the diameter of the tolerance zone. The letters A, B, and C are reference datums. So, maximum material, least material, etc. Effect of the MMC modifier on position and balance tolerances. So, this kind of shows you what I was talking about a while ago. So, if it's a 500 hole, you got plus or minus 2, so you can be anywhere from 498 to 502. So, if you're smaller, then your tolerance zone is only 4 thou. Whereas if you're at 502, then you got an 8 thou tolerance zone. And same thing for the least. Alright, so circular runout requires the TIR, total indicator reading, when rotating the part to be within a specified tolerance at any one location. In this case, the datum diameter is first made to run true. Then the TIR is checked at one location on the surface noted by the feature control frame. Next, the indicator is moved to another point and the TIR is checked again. This is done at several locations along the part length. If TIR is within tolerance amount at each location, the part is acceptable. Total runout. Total runout requires the TIR when rotating the part to be within the specified tolerance at every location in this case. The datum diameters are first made to run true, then the TIR is checked at every location on the surface noted by the control feature frame. By moving the indicator across the part while rotating it, if the TIR is within the tolerance amount across the entire surface, the part is acceptable.